The Latur earthquake of September 30, 1993 had a magnitude of 6.4 on the Richter scale. By the international standards, this was only a moderate earthquake. However, more than 9,000 people died, about 10,000 houses demolished completely, and another 20,000 destroyed. Besides, hundreds of thousands of other houses have been cracked or shaken so badly that people are very much terrified to enter those homes. The question arises, in such a moderate earthquake, why so much of destruction of the housing and death should occur? The reasons are the heavy stone buildings without any earthquake resisting features, very heavy roofs, and very poor mortar. So all these combined have resulted in this colossal damage. Let us consider the type of construction in that area. The walls are very thick, from 60 centimeters upward to about 120 centimeters. The walls are constructed in two layers of stone, one inner layer and an outer layer, in which better stones are used. But in between, in the hearting of the wall, mud mortar, small stones, round stones are filled to make up the total thickness of the wall. Now such a wall has very small strength against shaking. When shaking occurs, the two layers of the walls inside and outside, they tend to fall apart, and then the whole thing crumbles, and the roof resting on such walls crumbles along with it.
Most of the structures which we see around here, they are around 100 years old and done by the ancestors of the people who are living right now. And over the years they have done nothing to strengthen these houses or to repair these houses. But whenever there used to be some leakage of water, so they used to put a layer of mud on top of the existing roof. And now we see that most of these houses, they have around 3 to 4 feet thick layer of mud on top of that, and that puts tremendous load on the columns, on the beams and the walls, which are already weak. Their life is already over because of aging.
In many cases, even grass grows on the rooftop, which adds to the porosity of the roof and the weight on the roof. Another weakness of these stone houses is that at the corners there is hardly any bonding between the perpendicular walls. The walls being so thick and the stones being not very long, and the walls got separated at the corners, and therefore their collapse was very easy. Many of the houses in the Marathwada region where the earthquake occurred have a very special feature, which is a timber frame, which in a way is pin jointed at top and the bottom. The whole roof rests on such wooden frames. In some cases, the wooden frame also collapsed with the walls and the roof, and therefore people got buried and died. In many cases, however, this wooden frame saved the people, because in the process of the collapse of the walls, the wooden frames, when they got tilted due to earthquake forces, they got supported by the fallen debris, and the roof did not collapse completely, and therefore the people came out alive from under these frames.
ये लकड़ी के घर में हम तो कभी भी नहीं रहेंगे, लेकिन वो जो पतरा है ना, वो पतरे का घर बनाना और पतरे के घर में रहना, अगर ये लकड़ी के घर में हम कभी नहीं रहेंगे, नहीं रहेंगे।
Now the present situation in the area is that the people who are living in such homes, not in the affected districts themselves, but in districts all around, they are so terrified to enter these stone houses that the life has become very miserable for them.
हर वक्त ये भूकंप के धक्के बैठ रहे हैं और ऐसे घर में अगर एक भी धक्का ज़्यादा धक्का हो गया तो कोलैप्स हो जाते जल्दी, इसलिए हमको डर लगता है।
So far as the stone houses are concerned, the weaknesses of the stone houses as they are in the Marathwada area are the reasons for their collapse. Not that the stone houses cannot be constructed which will be earthquake resistant.
जो गांव का एरिया है उसमें ज़्यादा धक्के बढ़ते हैं और उसी वक्त जब हम नवीन एरिया में जाते हैं वहाँ कुछ महसूस नहीं होता ज़्यादा, हार्ड रॉक है।
And somehow they have been given to believe that those houses which were supported on hard rock or on muram, they were better off than those which were supported on black cotton soil. However, the observations during this earthquake have clearly indicated that there were absolutely no foundation failures and there was hardly any difference between the collapses in the villages which were founded on hard rock or on muram or on black cotton soil. It is the technology of construction of these stone houses that is the reason for their collapse. Now, what is that improved construction technology? The stone building should have a few essential points. We use the term retrofitting for providing measures for strengthening against future earthquakes in existing buildings. Retro means after. And this methodology of improving the strength of the existing building we call as seismic retrofitting.
So to strengthen these walls, the idea behind making these holes and again putting concrete in that is one layer in the front, one layer in the back. So when we do the concreting inside, the whole wall gets connected.
So in this process what we do is we take a stone from outside, we take a stone from inside, make a through hole, then insert a steel bar and then put concrete in it. So it becomes a complete plug from inside face to the outside face and the whole wall gets tied together. The second step is to reduce the weight of the earth on the top by removing the whole earth from the roof and then laying in this in two layers. First a layer of 10 centimeters, then a polythene sheet on top of it going into the parapets, and finally a layer of another 10 centimeters on top, and on top of it the waterproof mud plaster. So this 20 centimeter thickness will be quite enough to provide the thermal comfort as well as the waterproofing against rainwater. We have to strengthen the inner wooden frame, and this can be done by introducing what we call as the knee braces. Now since the earthquake can come from any direction, knee braces have to be introduced in both perpendicular directions, that is within the frame and in the longitudinal direction of the frame.
When the earthquake happens, it's a horizontal force which shakes the whole structure, and to take care of these horizontal forces we have these diagonal members or the cross bracings. So it connects the beams to the columns, and then this whole timber structure becomes more stable and it can take the shaking force of, it can counteract the forces which act horizontally on the columns and the beams.
And then the installation of the ramban or the seismic belt around the house. Now this is the next step to be taken, and in this what we do is we remove the outside plaster, whether it is mud or lime, we rake the joints, then we put a welded wire mesh all across the walls along the length in the kind of a belt around, And at the corners we provide a little overlap like this. From one end it's coming like this, from the other end it's coming like this, and overlap here. And the meshes are held to the walls by long nails, and then these meshes are covered by what we term as micro concrete or simple plaster with 1 part cement, 3 parts coarse sand, and the plaster thickness is kept about 30 millimeters or 3 centimeters, so that we make it completely waterproof, so that the mesh that we put inside does not get corroded with time. Now if we install this, and where the rooms are very long, then we can also introduce cross ties, that we have the one belt here, across we put a cross tie, and then we tie these together, so then the whole house gets not only tied from outside but also from inside, and it becomes one whole integrated unit, and it will not be shaken apart by the earthquake. So by these simple devices, let me repeat, the strengthening of the wooden frame, reduction of the weight of the roof, the stitching of the walls by those plugs, and a seismic belt all around, we can make a house as strong as we please. Two houses in Mugarga have been retrofitted in this manner with a expenditure of about 15 to 20% of the reconstruction cost. This is something that people can afford. This is the solution for the millions of the houses that are there. And once this gets done in this area, this will be a very shining example to the whole world, not only in India. Many countries of the world have stone houses. So there is no running away from stone houses. The stone houses have to be there, will be constructed because of the local availability of stone. What we have to do is we have to learn how to use stone in a proper earthquake resisting manner. And the methodology indicated here is very cost effective, very simple, which can be learnt by the people, and they can protect themselves from the future earthquakes.